With PTC Creo Parametric, designers can build assemblies using mechanical connections. This enables them to investigate the motion behavior of their designs under real-life conditions. Using Mechanisms Design, you can detect collisions between moving parts and quickly understand the kinematic implications of design changes. In this case, we are investigating a gearbox design. Having created the assembly using mechanical connections, we can capture snapshots of the gearbox in different positions. And since the assembly is now a fully detailed mechanism, not a static assembly, we can change the position by simply dragging the gear shift. We can now run a dynamic interference check on the assembly. As the mechanism moves through its range of motion, PTC Creo Parametric will detect interferences and collisions between parts. At the same time, you can also establish a motion envelope to avoid collisions as you add new parts to the assembly. We can also analyze the kinematic performance of the design. We begin by applying a prescribed velocity to the input shaft. This enables us to establish the testing parameters for the gearbox design. The velocity profile we have established is now easily visualized with a graph, and all the analysis parameters are available in the mechanism tree. Now that we have established our input conditions, we can use our captured snapshots to reset the assembly to the desired starting point. PTC Creo Parametric can now quickly analyze the mechanism performance for each gear in real time. And once the analysis is complete, you can quickly review the results graphically to better understand the performance of the mechanism. These results can then be used to optimize your design or to confirm that it meets design requirements. Another advantage to working with PTC Creo Parametric is the ability to drive your design using PTC MathCAD. This enables us to make changes to highly complex mechanical assemblies, such as this gearbox, quickly and easily, with the confidence that the design is fully documented and reusable by other team members. By opening the PTC MathCAD table directly in PTC Creo Parametric, you can easily switch parameters, in this case the track type, to change the gears. The mechanical assembly then automatically updates to reflect the new design. With the new mechanical assembly in place, you can easily rerun the previous kinematic analysis. The existing analysis is captured in the mechanism tree. You can simply make a copy of this analysis and use it with the updated design to ensure consistency. And all of this is performed using context-sensitive menus, significantly improving your productivity. Finally, you can view the analysis results graphically, comparing the original and the new gearbox designs. In this case, it clearly reflects that the design changes have resulted in improved performance. PTC Creo Parametric provides a powerful, easy-to-use environment for designing mechanical assemblies. And by providing a comprehensive toolset specifically developed to analyze mechanism designs, you can fully understand and optimize their performance and behavior.